Hello, good evening everyone. Am I audible?
Yes, ma'am.
Good
Okay.
evening.
Yeah, good evening. Okay, so this is my first session with you. I am Manideepa. I'll be one of your course instructors for PDS at this time. I'll only be taking your these live coding sessions for every week, right? So as you know that before the session starts, half an hour before, we will release the questions and now we will solve them together, right? So for week 2, we have 4 questions. We'll solve them one by one. I am going to use Spider. You can use any ID of your choice, right? Or you can solve on the Seek portal also. Okay. So there has been a theory session for this week, right? Week 2. The content of week 2 has been discussed.
Yes, ma'am. The initial part, yes. I am not aware if all types of algorithms are covered or no.
Okay. I'm hoping that all of you have at least gone through the lecture material, right? Because I was only asked to discuss these 4 problems today. So I'm going to do that. But in that, while we are covering that, whatever queries you'll have, we'll discuss. Okay. So
Ma'am,
everyone, yeah.
one query. Yesterday we had a lead code session. Okay,
Okay.
some problems from lead code were taken in PDSA.
Okay.
Uh, uh, my doubt is we found the difficulty level, at least in terms of time, little harder. So
Yeah.
like developing logic and coding was taking time to solve those lead code problems.
Right.
So
Because
what is
these are see lead code problems are a little advanced level, right? And you are just learning. So data
yeah? So
structure will take some time.
okay, they were algorithmic only, not
Yeah, yeah. But
data
see, these
structure.
are very initial weeks, right? So you have very basic concepts till now. I mean, only searching, sorting part we have done. There's a lot more to cover. And obviously, as we go forward in the advanced weeks, these basic concepts will come back again and again, right? While solving more complex problems, you will need to apply this searching, sorting techniques also.
Yeah,
So more
correct. They were
problems
good
you
for
solve,
practice.
you'll get it easier. Okay.
Yeah, my question was the difficulty level of OPPs and all, how it will be. It will be comparable to
Difficulty
those.
level will be you can compare it to these live coding problems. Okay.
Okay, live coding or grade
Yeah,
assignment
graded
problem.
assignments, practice programming assignments, that same level.
Okay,
Lead
right,
code
ma'am.
problems you can solve more for your interviews like coding rounds. For them, it's good.
Understood. Understood.
Okay. So everyone, please open that portal and you can see the 4 coding problems for week 2, right? So I'll start with problem number 1. I'll share my screen 1 second. Okay, is my screen visible?
Yes, ma'am.
Why are all these people asking me to, get admitted in the meeting? Can't you directly get admitted?
For IITM ID, they can, but if they are using their personal,
Personal ID, okay. Yeah, okay. See, this is the first problem, right? So, mainly in this, if I have to keep going back to do this, it's going to be very difficult. So, this week we have mainly searching, sorting, right? So, first week was just introductory Python code basic. Now, this is the initial part of DS, right? So the types of searching sorting algorithms that we have learned, like insertion, bubble sort, right, quick sort, merge sort. So these sorting algorithms that we have learned, those are going to be applied in these problems. Okay, and the basic searching techniques, binary linear search. So I hope you're comfortable with timing complexity, right, of these algorithms individually. Because see, in these problems, it might be mentioned that what complexity we want in the solution you're providing, right? Like in this particular question, you see. So let's understand the question first, then we'll write the code. So it is saying that write a function called find peak. right, which takes a list as an argument, and the list will contain n distinct elements, and it will return the peak element of the list. So peak element means what? So in a list, the element that is a peak will be if that element is greater than its neighbors. So that means if this is my list, right, the sample input 5, 10, 20, 50. So we have to check for all these elements which one is the peak. So there are two different types of elements. One that are present at the boundary of the list, right, at the starting, at the end. So those elements only have one neighbor, right? For 5 there is only one neighbor, 10 for 15 there is only one neighbor, 20. But for 20 there are two neighbors, and for 10 there are two neighbors. So we have to find that element which is the peak element that is greater than all its neighbors. So that element can be present at the boundary also, can be present in the middle of the list also. Okay. Now for corner elements, we need to consider only one neighbor, like I said. We need to write a solution that will take order of log n complexity. Okay. And we have to consider that there is only one peak in the list, not more than one. So just, I hope the problem statement is clear to everyone, right? What we have to do. Now coming to the complexity, it is saying order of log n. So basically, what are we trying to do? We are trying to search, right? We are trying to search an element which will satisfy all this criteria. So what is the searching algorithm that we can use which takes order of log n time?
Binary search.
Binary search.
Binary search, simple as that, right? So we will apply binary search to this. It is simple binary search with a bit of twist, right, where we have to check these conditions. That's it. So let's start writing the code. Problem statement is clear for everyone? Any doubt?
In this case, only the max element will be the peak always, right?
Max element will be the peak. Now what happens, it can be present in the boundary also, in the
Yes.
middle also, right? So if it is present at the boundary, then you have to check only with one neighbor. Now we don't know what is the max element in this. Okay, now we want a order of log n complexity. I have no idea that what elements are there in the list,
Mm.
right? So we cannot directly search for the max element and say. So
Okay.
here we are trying to see. Theoretically, if I think about this problem, definitely max element has to be that, right? But here we are trying to apply that searching technique. That for this, if I define a problem like this, it is just defined in a creative way. But yeah, if you are smart enough, you can think of it like that. Then obviously the max element will have all its neighbors less than that, right?
Oh, ma'am, but why are we using binary search? Because we do not have a sorted list. How can we use it?
In this particular case, you don't need a sorted list. Okay, so there are some special problems for which you can use binary search without having a sorted list. Okay, we'll see how it will work. Usually binary search doesn't work if it's not a sorted list, but in this case it will. Okay, we'll see. So you can also write the code along with me. Is the spider terminal visible to you?
Yes,
Yes,
ma'am.
ma'am.
Okay, one second. So first, see, we
You
have to.
can zoom in a little bit, ma'am.
Yeah, I'll zoom it. Okay. Uh, is this visible? This size is okay. Font size.
Ma'am, can you increase the brightness?
Uh, okay.
Size of letter is okay.
All right. Now, first thing is we need to take a list as input, right? You will take that list as input, then we will call some function which is called find peak, which will do the rest of the work. Okay, now here I am going to be using one more function called find peak util. Okay, so in find peak function, I'll just take the list and take the length of the list, and then I'll call that find peak util function, which we will do, which we will write, which is the actual logic behind it. Okay, you can write it in one function also, it's fine. So first let's take input. So L is the list, right? L will take a list input. So eval input. Inside this you can also write something like enter the list. Next we are going to call the function which I'll define later on. I'm just writing the actual suffix code, okay, which will be actually visible to you if you do it on your during your OP or in the portal itself. Okay, so I'll take a variable called res. In this, I will call the find peak function. Okay, find peak, which will take L as argument. Then print whatever is returned by this function. Okay, why is okay? Find peak is not defined. I'll define that now. So this is the base code. Now we are going to define the functions. The first function I'll define is find peak. Let's start from here. So def find peak. It will take that list. Now we need to store this length of the list in a variable. So I'll take a variable n. Inside this I'm storing length of L. Okay. What will this return? Now I will actually call that other function that I'm going to write, the utility function. Okay, so return find peak util. Now the arguments in this is what? First it will take the list. Okay, then it will take the lower index, that is 0. Then the higher index n minus 1, and lastly n. Okay, that is the number of elements in the list. So these are all the arguments. Now I will write this function. So this is the actual function in which you will understand the logic. Okay, so def find peak util. So this takes the array or the list. It takes the low index, the high index, and n. Okay. Now first we need to find the midpoint. Okay. Whenever we do binary search, we start with the midpoint. So start with mid. Mid is equal to what? What will be mid? Tell me. How to find midpoint?
Low plus high by 2.
We can do low plus high by 2. Okay, that is how we do in general. But sometimes in Python, an integer overflow can occur. Right?
Length of list by 2.
So what we can do is low plus high minus low by 2. Okay, this thing will give the same result. So this is just to avoid that overflow. If you have a very large list of numbers, right, then it can basically go out of range of integer. So that's why we do this high minus low by 2. We'll give the same thing. So low plus, you can use low plus high by 2 also. Okay. Low plus high minus low by 2. So this is your midpoint. Now we are going to convert this into integer. So it can be a decimal value also, right? Since we're not doing floor division. So we have to convert that to integer. Now after this, now you tell me what is the logic. Okay, there are two things I need to check. Whether my midpoint is a boundary. That means whether it lies at the beginning of the list or it lies at the end of the list. One more thing is that I need to check that whether this midpoint is greater, like whatever is stored in this mid index is greater than the index before it and also greater than the index after it, right? In case if it is not a boundary, then you have to check for both neighbors. So I can write an if condition after that. If, now I'm going to check these conditions. Mid equal to 0. This is for which boundary condition? If the element I'm looking at currently is at the beginning, right? 0th index.
And which means the list will only have one element, right?
So this will actually come when?
When the
Is
when the
it
list will
only
only have
when
one element.
is it only when the list contains one element?
Oh, no, ma'am, it's possible when it's
It's
having
possible
two
when,
elements.
yes, any number of elements. Okay, it can be that the highest element is at the boundaries. So then this condition will become true. Okay, and let me write the entire condition, then I'll explain again. So either mid is 0 or whatever is present at the index before that mid index, so mid minus 1, is less than whatever is present at the mid index. So that's what we want, right? We want it to be less than the peak. So this is one condition. Another condition that has to be satisfied along with it is, and if mid can also be what? N minus 1, that is also a boundary condition. Right, that is the last one, last element. Or, so what do you think will be the next condition?
Mid array of mid is greater than mid plus 1.
Array of mid is greater than mid plus 1, correct. So mid, let me write like this, mid plus 1 is less than array of mid. Okay, now let's understand this again. So if this is my condition, that means what am I checking? If it is a boundary, okay, see, if it is at the first index, if my highest element is present at the first index, then at some point this will become true, mid equal to 0, right? Up to this is clear. Mid will become 0 at some point if the highest or peak element is present at the first index.
Ma'am,
0
we are
element.
referring mid as an index, right?
Yes,
Index
mid is
of
an index. Okay. So if that is the case, then which neighbor should we check? If mid is the first index, which neighbor should I check? Mid
Right.
plus 1, right? Mid plus 1. So on the right side.
Second one.
So this condition should be true. If it is true, then with that, which other condition should be true? This one. Mid plus 1 should be less than mid. Again, for the other boundary condition, if mid is the last element, that means we find the peak at the last element of the list. That means n minus 1th element. So this mid equals to n minus 1. If this is true, then along with it, what else should be true? That mid minus 1 is less than mid, right? That is the left neighbor is less than that. So this should be true. So either these two. Third case is what? If mid is not at the boundary, right? Mid is some middle element, some middle index. In that case, which two should be true together? This one and this one. So if mid is the peak and it is not present at the boundaries, that means it is present somewhere in the middle indices. And in that case, there are two neighbors. One is mid minus 1, one is mid plus 1. So both neighbors should be less than that, right? So both these conditions should be true. So all three can be checked in this one statement. Is this conditional statement clear up to this?
Oh, ma'am, can you please repeat once, ma'am?
Yeah. See. Now mid is what? Mid is where we will find the peak. Okay, whatever is the peak. Okay, that will
We
be
assume
found.
that mid will have peak.
Yes. We are
Okay.
assuming that mid will have peak at some point.
Yes.
Okay, this is a recursive function. So we will
Yes.
call this again and again. This is recursive binary search type algorithm.
Yes, ma'am.
So mid, first of all, if the peak that we find at some recursive point, if we find that the peak is at the boundary that is at the beginning of the list, that is 0th index, the peak can be present at the 0th index also, right?
Mm-hmm.
So in that case, mid will become what? 0.
Yes.
Ma'am,
If mid is,
if it is at the starting index, if we put mid minus 1, will it not cause index out of range error?
no, we're not putting mid minus 1, no? We're putting
So
mid
array
0.
of A or mid
This is
minus
mid
1.
minus 1. If, see, either this will happen, either this will be true or this will be true. These two will not be true together. Okay, that's why the
Okay.
or condition is there.
So
If
which means
this
if
is
it is
true,
at the start index, it will not execute. So that is
no.
what you're
Start
saying.
index will always start with 0. That's why the lower point is set to 0. Okay, low is always 0. So if mid is 0, then along with this, there is an and condition. That means something else also has to be true. So if mid is at 0, peak is at 0th index, then this should be true. That mid plus 1 should be less than mid, right? That means the right element, the
Yes.
first index
Yes.
element should be lesser.
Less than mid. Okay.
Okay. Either, so this is one case. Another boundary case is what? If mid is at the last index, that is n minus 1th index. So if this is true, okay, along with it, what will be true? This one. That mid minus 1 should be less than mid. That means the left element, n minus 2th element, that should be less than mid, right? These are the two boundary cases. Now what happens if mid is not at the boundaries? If mid is at the middle indices somewhere, then mid will have how many neighbors?
Ma'am,
Two.
we could have also written like mid is equal to 0 after that end condition and
Yeah.
that
This is, see,
corresponding
you
could
can
have.
write it in a more broken down manner also. Okay. I'm writing in
Yes.
one complete line. You can break it down.
Okay.
So now if the middle element is at one of the middle indices, not at the boundaries, then how many neighbors will it have?
2.
Two neighbors. So in that case, which condition should be true? This condition should be true, that the left neighbor is less. Also the right neighbor has to be less. So this condition should also be true. So when these two are true together, then I know that mid is not at the boundaries. Mid is at the middle, somewhere at the middle, right? So all three cases can be checked in this one if statement. Up to this, any doubt?
Ma'am, can I see the statement after and?
Yeah, wait, let me minimize. Wait, somebody is again asking to join. If you have a group or anything, can you please tell your classmates like to join from their official ID? This is very hard, right? Okay. Yeah. Any doubt till now?
Ma'am, you told something about that overflow.
Yes. So why we are using this high minus low by 2, right? Instead of just low plus high by 2. So sometimes this high can be a very large number. Okay, if the list is very large, if it has a lot of elements, high can be a very high, large number, large index. In that case, it can sometimes even go beyond the range of integer, right? So that's why we do this high minus low to make sure that that overflow doesn't happen. Okay, see, later on when I do this, like when I do the recursive calls, low will not always remain 0, right? Low will also increase or high will decrease, something will happen. That's how binary search works. So high and low will keep changing for every recursive call. It starts with 0 and n minus 1. Okay. So in that case, if it is a very large list, then to get rid of this overflow so that this never happens, we have this high minus low.
But this high plus low can like at most go to um, two times high, right?
Yeah.
And
But
even
high
below
can
that.
be a very large index.
But for first instance, ma'am, high minus low, when low is 0, can still cause overflow, no? So
Yeah.
if
So
high
for
can.
first index, it can still cause overflow if it is a very high list. Okay. So that is one thing. But it will get rid of most of the cases where it can happen. Okay. I'm not saying completely eliminate overflow, but it can get rid of most of the cases. Okay, but the test cases that we are using are not that high index, so it's okay, but it's better to take like this because you don't know what the test case will be. Okay, yeah, up to this, now ask me any other doubt or should we continue? Okay, so now if any of these conditions are true, right, then I can directly return mid. That means I have found the peak. Is that fine? I can write return mid, right? If it is not true, if this if statement is not satisfied, if none of the cases are true, that is I haven't found my peak yet, then I have to keep looking for other cases. So next I'll have an else if statement, elif. So elif, what is the other thing that can happen? So if
Both.
mid is, let's say mid is greater than 0. Okay, if mid is greater than 0, then that can be one more case. So I can write else if mid is greater than 0. And what should be true if mid is greater than 0? Add a
Add of mid minus one less
mid minus 1.
less than add of mid.
No, greater than. If that is the case, okay, I have to check for every case, right? If mid is greater than 0, that means mid is not at the boundary, or at least at the beginning boundary, it is not there. It is not at the 0th index. So if mid is greater than 0, at that time, if the case happens that whatever is the left neighbor of mid is greater than mid, then can I say that this particular mid index is a peak? If any of the neighbors are greater, can it be a peak?
No, it can't.
It can't be.
Ma'am, can you
Never
please
can be
repeat what you
smaller.
said, ma'am?
Yeah, right. See, relate this with your binary search recursive algorithm, right? So what is the other case? First case, very good. If I find my mid at one point, great. Okay. If I don't find my mid, that means mid is at some index other than 0. That is, mid is greater than 0. Okay. And this case is true that the left neighbor of mid is greater than mid itself. Then the current mid index, can it be a peak?
No.
No.
No, because the left neighbor is already greater. So if I know that left neighbor is greater, then which side of the array will I check?
Right, sir.
Low to?
Sorry, left is greater than, we'll check left side.
Yes. So we will go from low to mid minus 1, right? Low to mid minus 1 we will check in this case. So if these conditions are true, then return. So this is the recursive call. Find peak util. Again pass that same array low, mid minus 1. Let me put this within parentheses. And n. This recursive call will do what? It will now shift the search to the left side of the list. Okay, because we have apparently found an element which is greater than some other element, right? If the current mid index is not the peak because the left neighbor is greater, that means there is a possibility that the left neighbor might be the peak. Correct.
Yes, ma'am.
So we need to search in the left array. Okay, so we'll search in the left array first. Now, what is the other case that is possible? The other else condition? In binary
Peak
search,
is in
what
the
do we
right
do?
side.
Correct. That means the right hand neighbor of mid is greater. So if mid plus 1th element is greater than mid, then we will search in the right part of the array. So we'll return again, find peak util, pass the array. Now, what is the lower index?
Mid plus one.
Mid plus 1. This is the lower index. What is the higher index? High. Right,
Uh,
till the end of
n
the list.
minus one.
Yes. So n minus 1 is basically high here, right? This is the function definition. So I'm
Yeah.
not using n minus 1. So high and then n itself. So these are all the cases that can happen. This is basically how we write binary search also, right? Either one case is what? The first if is that you have found it. You have found your kth position where the element you're searching for is present. If you haven't found it and the current mid is showing that the mid element, whatever is at the mid element, right? K is less than that, then you search in the left part of the array. And if K is greater, then you search in the right part of the array. Same logic here. If you find a neighbor on the left hand side that is greater in value, that means there is a possibility that that neighbor might be the peak element. So we will search in the left part of the array. And if you find a right neighbor, right, which is greater, that means that right neighbor could be a peak, could be the peak we are looking for. So we'll search in the right part of the array. Since there is only one peak, that's why this works. If there are multiple peaks, it cannot. Okay. So this is the logic. Now we have to write that, okay, no, we have already written find peak. So what will happen first? I will input a list here, right? Then this res, inside this res variable, I'm calling what? Find peak with the list. So it will shift the control to this line. It will go to the function definition. What it will do is check the length of this list L that I have entered and it will store it in N. Next, in the return statement, it will call what? Find peak util with these arguments. So now control shifts to here. Now let's take an example. Okay, first let's check if this is working. So let's take the test case that is given over there. Right, what is the test case? 5, 10, 20, 15. Let's run this. So 5, 10, 20, 15. It should give me 20 if it is correct. Yes. Okay, one more test case let's run for boundaries. So let's, for boundary, we can take a sorted list like this, right? 5, 6, 7. Other case also you can take. This is just one case. So 8 is the peak. Okay, that means this is working. So what is basically happening? Let's take this list. 5, 10, 20, 15. Okay. So 5, 10, 20, 15 is first taken as input, then it is sent to this find peak definition, function definition. What is the length? 4. So n is 4. Okay. Do you want me to write this? Do a dry run? Will that be easier to understand?
Yes, ma'am.
Okay, let's do a dry run quickly. Just a sec. Okay. Now see, this is our list. Is the PDF visible?
Yes, ma'am.
Yes, ma'am.
This is my list, right? This is my test case. So first, inside res, we are calling find peak. This is list L. We're calling this with the argument. Fine. Now, what is find peak doing with it? It is first extracting the length. So what is length of L here? 4. Okay, then it is returning what? It is calling my find peak util function. So find peak util, and it is passing what? The list L, 0th index. What is n minus 1 here? 3.
3.
And what is n? 4. Now control shifts to this function definition. Now let's match it with the code while we solve. Right. So what is this doing? Find peak util. First we have to find the midpoint, mid of the list. So what is mid? Low plus high minus low by 2. What will I get if I solve this? What is low? 0.
0.
5.
What
3
is
by
high? 3.
3
So
minus 0 by
basically
2.
it is what? 3 by 2. That means 1.5.
Yes, ma'am.
Right. So if I do the integer of this, it will get rid of the decimal part. Right. I'm taking int of mid. That is being stored in mid. So if I take int of this, what will I have? 1.
Yes, ma'am.
Okay. Now see next what the code is doing. It is asking that first if condition. So now you check if mid is equal to 0. So is mid 0?
No, ma'am.
No. Okay, let me write it once quickly. If mid is equal to 0, or what was it? Array mid minus 1 is less
Is
than
the array of
array.
mid.
Okay, so either one of these is true, and along with it mid is equal to n minus 1, or array mid plus 1 is less than array mid. This was the if condition, right? So now check for this. This is the first recursive step. So mid is 1, right? Mid is not 0. Is mid n minus 1? N minus 1 is what? 3, right? So this is also not true, this is also not true. Check these conditions. Mid minus 1, that is, mid is 1, mid minus 1 is what? 0. So is the 0th element less than the 1th element? Yes.
True.
Okay. So this is 0th element, this is first element, which is less. This condition is true, but still I need this condition to be true. Right. Is mid plus 1th element less than mid? That means is the second index less than the first index? Second index is having 20, which is not less. That means if condition violated. So I have to go to else if. Else if what am I checking? I'm checking if mid is greater than 0 and add a mid minus 1 is greater than add a mid. Okay, I'm just writing all the conditions so that we can do all the iterations, right? So if mid is greater than 0 and add a mid
minus
minus
1.
1 is greater than add a mid, right? Check this. Is this true? So mid is greater than 0, fine. Is this condition true? Is mid minus 1, that is the 0th element, is it greater than mid? Is 5 greater than 10? No. So this condition also violated. So we have to go to the last else. So what was the last else? If this condition also violates, then it was just a return statement, right? Because if the left neighbor is not greater, that means which neighbor is greater? Right neighbor, right? If both neighbors were less, that means it would have been the peak. It is not the peak. And we know that left neighbor is less. That means right neighbor must be the one that is higher. So what we are returning? Tell me the return statement. What was it? Find peak util.
Comma 2.
So you start with this array, that is the list that we have. What is the beginning index?
Mid plus 1.
Mid plus 1. How long are we searching till? High and n. So this is the condition where we will go after the first iteration. So this condition violated, this condition violated, so else is the only one left. So we have to go here. That means this is the first recursive call. Now control shifts to this call, which is the second call. Okay. Actually, you can think of this as the first call. Let's call this 0th, let's call this first. Okay, because recursively it has been called only once. So this is the 0th, this is the first call. So again now we have to do this find peak util function one more time with these. So if I write find peak util, okay, what are the actual arguments? The list L. What is mid plus 1?
2.
2. What is high? 3.
3.
N is 4. Right. Now again check the same conditions. We have to find the mid again. So what is mid right now? What is mid? What was the
0.
formula? Low plus
high minus low by 2.
high minus low by 2. So what is this? What is low? 2. What is high? 3.
3.
3 minus 2 is 1 by 2. So what are we getting?
2.
2.
This is, wait 1 second. We are searching on the right side index. So it is starting at this index, right? So the midpoint is what? 2. When I convert it to integer, I should take this 2 as my mid. Now check the first if condition again. Is mid equal to 0?
No.
Mid is 2. Check this condition. Is mid minus 1 less than array mid?
Yes.
Is mid minus 1 less than array mid? So mid minus 1 is what? The first index, 1th index. That is less than array mid. 10 is less than 20.
Yes.
Satisfied. This condition satisfied. Now and one more condition. Is mid n minus 1? N minus 1 is 3. Mid is 2. So no. Check the other condition. Is mid plus 1 less than array mid?
Yes.
So mid is 2. Mid plus 1 is this. 3. Third index. So 15 is less than 20. So these two are satisfying. This one is satisfying. This one is satisfying. So if both satisfy, I can do the return statement. What is the return statement? Check the code. Just return array mid. So what will I return at this stage?
Array of
Array of
2.
1. I'm sorry, 2. Array of 2. So what is this element? 20.
20.
So is 20 the peak?
Yes.
Yes.
So like this, you can check, you can dry run for any. Okay, for any list, just do a dry run. It will make it more clear. Okay. So when this is returned, where is it being returned? To this find peak procedure, right? Find peak procedure. So this return statement in this line 15, I have written find peak util, right? So whatever this find peak util returns will be returned to this part, right? And find peak will return it back to this res variable. So ultimately res is storing this second index value, whatever it is. So array of mid or array of second index is being stored in res. Then you just print res. Is this code clear? Any doubt, any part? Okay. So should we go to the next problem?
This is live practice session.
Yeah, this is live session,
Ma'am,
live coding.
small doubt.
Okay. So next question we can
Hello,
start,
ma'am.
right? Yeah.
One small doubt.
Yeah.
In line 5, there's a if statement, right? I have modified a little bit in that if statement, and I have pasted that code in the chat box. Can you check if it
Yeah.
is the same logic or not?
One second.
Only the line 5.
Let me check. So you're checking if mid is 0 and array of mid plus 1 is less than array of mid. Oh, okay. You're just no, I don't think this will work. See why this won't work if it is present at the boundary condition, right? If it is present at 0, okay, 0th index. If peak is at 0th index. Okay, you have changed the or condition also, or and end.
Yep. Yes, ma'am. A little bit rearranged.
Yeah, this is fine. This will work.
The logic is same, right?
Same. Yeah, I didn't notice that and or you have changed. Yeah, this is fine.
It is just De Morgan's
Yeah,
decomposition of the way
it's
of
just
writing.
decomposition. Yeah.
Okay.
Okay. Okay. Next problem. Let's see.
Ma'am,
Yeah.
this question assumes that there is only one single peak, right?
Yeah. Only one peak. It is written in the question. See, consider that there is only one peak.
Okay, sorry.
Okay. Now the problems will get a little bit tougher, right? So second one is, I think this is based on that same. Yeah, this is a good problem. See, so now this is saying that we need to write a Python function called find common elements in two lists L1 and L2, right? So basically this function should accept what? Two integer lists L1 and L2 of same length n, okay, and return a list that contains the elements that are common to both lists. Okay, last question that we solved, the timing complexity will definitely be order of log n. Everyone agrees on that?
Yes, ma'am.
Because on every recursive call, right, we are splitting the list into two halves. The mid, whenever we are calculating the mid, we are splitting it into two halves in the next recursive call. So that's log n. In this problem, what it is saying, we accept two integer lists L1 and L2 and we return a list that contains elements that are common to both lists. Okay. So only the common elements, intersection of both lists. So write an efficient solution that runs in order of n log n or better time. Okay. So L1 contains all distinct integers, L2 contains all distinct integer, but there can be many elements in common between L1 and L2. That means inside L1 and L2 there are no repetitions. Now returned list contains all elements that are common to L1, and the elements in that returned list can be in any order, right? So there is no such order that we need. We can sort it to make it look good. Okay, that's it. So problem statement, see, look at this example. So list 1, if it contains 582, list 2 contains 681. 8 is only the one element in common. So find common element, list 1, list 2 as argument should return this list containing just 8. If there are multiple common elements like this second example, 375, all are common. So this list is written 375 in any order. Okay, the element order doesn't matter. So problem statement is clear for everyone what we have to do.
Yes, ma'am.
So next,
Yes.
our next concern is that we need a solution that runs in n log n time or better. So let's first attempt n log n. So one thing we can do is in this code, okay, first you tell me if you have any ideas.
Ma'am, we can convert the list into sets and
No,
then,
actually, we will mention this. See, do not use Python set built-in function. No set. So set will make this very easy.
yeah.
I have
We
one
want you
idea.
to write the, yeah, tell me what
Um,
idea.
We will traverse linearly through one list and search
yeah,
every
binary
element
search
Correct,
in
with
line
binary
2.
search in the second
correct.
list.
Yeah.
That's the most
We can
optimal
use
idea,
a
right?
lambda function to search.
So this will take, see, uh, what you are saying is that we are taking one list, we will keep it as it is, one list we will traverse through, and every element we will search in the other list, right? And wherever we find a common, we'll append it to a new list. Okay,
Yes.
that's the idea. So this searching that we are doing, can we do it using binary search?
Yes, ma'am.
Yes, ma'am.
Okay, but if we implement binary search here, do I need to sort the list in which I'm searching?
Yeah, both have to be sorted.
No, both don't have to be sorted. The list
That's
from
One
which
modern.
I'm
one
picking the
list to
element,
be started.
right? If let's say I am picking the elements from list 2 and searching in list 1, so only sorting list 1 is okay enough.
Yes, ma'am.
If I use the built-in sort function, that is Python takes something called a time sort, right? So that takes how much time? That takes n log n time always. Okay, that's the constant time it takes. The sort inbuilt function in Python, it is a mix of your insertion sort and merge sort. Okay, that inbuilt Python, and it takes Python sort. This takes n log n time. So since we are, see, two breakdown of this timing complexity thing. One is when you sort one of the lists, that will take an n log n time. Okay, which is the basic time complexity for merge sort also. Another thing is that you are picking one element, that is you're traversing through one of the lists, right? You're picking an element from list 2 and then searching. So this traversing will also take how much time? Order of n time, since we're doing linear traversing, right? So total time is what? Order of n plus order of n log n. So what is the actual bigger term here?
And login.
And
So total time complexity, I can say it's n log n, right? So that's a good solution. Okay,
No,
now
what
let's,
is
Ma'am,
what is the complexity for sorting?
for sorting the complexity is n log n.
And for doing linear search via one list and binary in another list, it takes n log n, right?
Linear search,
I mean, we can traverse through one list like
if you
n1.
want to just traverse through a list, it will take order of n time.
In,
Okay, if list has n elements.
okay.
And in
ma'am,
linear search, the worst case complexity is order of n.
Ma'am, once can you explain it again?
Yeah,
ma'am, just one thing, ma'am.
yeah.
Ma'am, if we sort both the lists, what we can see is the second list we can always search in first list. Let's say the first element of the second list is is less than or is greater than some fixed value in the first list. So probably we can ignore the first few elements in the first list so that
So
search
even if you do that, I'm not entirely clear on the procedure that you suggested. But if you want to sort both lists also, right,
Mhm.
it is not in any way making my timing complexity better.
Yeah, yeah. It has to remain n log n only.
Yeah, n log n only. But yeah, if you can implement it like that, you can do it and send me the code. Okay, I'll check once.
Okay, ma'am.
Okay. Now, yeah, you want me to say, explain this one more time, how we are going to proceed? Someone asked, right? So I'll just tell
Yes.
this one more time in brief. What we are doing is we have two lists. Okay, L1, L2. Our goal is to find the common elements and keep them in a separate list and print that list as output. Okay. Now, my or rather your idea was what, that we can keep one list as it is and another list we will sort. Let's say L1 I keep as it is, L2 or L1 I am sorting, L2 I keep as it is. Okay, so L1 is now sorted. Now I will traverse through every element in L2. Okay, I'll go through the entire list L2, pick up every element, search that element in list L1. If it is present, that means it's a common element, so I can append it to a new list. So the new list will contain only the common elements. So what is the timing complexity this will take? Since I'm traversing through list L2, right? Taking every element from list L2 and checking. So traversing linearly through a list of n elements takes how much time?
O of
O of
R.
n. order of n, right? And since we have to sort one of the lists beforehand, so that sort function we can use in Python, right? Dot sort. So that method will take how much time? It takes a default order of n log n time. Okay, it that you can look it up online also. It is a mixture of your insertion and merge sort. Okay, and we know that merge sort takes a n log n time, right? So because of this, the default time complexity of sort function is your n log n. Okay, so if
Bigger
I
we select.
yeah, so are both terms in my time complexity are what? Order of n and order of n log n. The bigger one will prevail, right? So n log n is your actual complexity of the entire program. That's our desired one, right? If you can do it in a better complexity, that's very good. So let's first try
Understood,
writing
sir.
the code. Okay. Okay, terminal is visible.
Yes,
Actually,
ma'am.
Yes, ma'am.
okay, check the font
So,
size.
ma'am,
Yeah,
what we are doing, we are traversing through one list and doing binary
searching, yeah,
search in another one.
binary search and doing binary search in the other list that is kept as it is.
Okay, so for each,
So we have to first write a binary search function for that, and we have to write a separate function for this find common elements, right?
mhm.
Inside that find common elements, I will call the binary search inside the for loop where I am traversing through the elements in list 2 or list 1, whichever you want.
Okay,
Okay.
for each element in one list, we are doing binary search in other
Yeah.
list.
Also, you can think of it like this. See, binary search takes how much time? Log n. For how many elements do I have to do this binary search? N elements.
N
So n
elements.
log n. Okay.
Yeah,
Okay.
got it.
So wait. Suffix code is. No, I need to write the suffix code. Okay, I'll write. See, A. You can read. This font is okay.
Yes, ma'am.
So let's first take two lists as input. Okay. So I'll write enter first list, or let's just say enter L1, and then in B we'll store L2. So eval input enter L2. Okay, two lists we have taken input. Now next we are going to take a variable called result, in which we will actually store the sorted the common elements list. Okay, so in result we will call a function that is, it's not defined yet, I'll define it. It's called find common elements. Okay, what will it take as parameter? A and B, two lists. Okay. Next, just to make my output look good, I want to sort it. You don't need to sort it. You can print it in whatever order it's already calculated in, right? I'll sort it. So result dot sort, and then we can just print it, print result. Okay, this is the basic suffix code. So now let's write the function. So we have to first define find common elements. Find common elements. So inside this function, what is it taking as argument? L1 and L2. What is the first thing I need to do? I need to sort one of the lists, right? In which I will be searching. So let's sort L1. So L1 dot sort. This will take n log n time. Next, I need a new list where I will store the common elements. So let's call that list L3. L3 is an empty list. Next, I need to iterate through the other list so that I can pick every element and do the search, right? So I need a for loop. So for item in L2. Next, what should I do after I pick an element? I need to check whether that item is present in L1 or not, right? So that I will do with the help of binary search. So if I'll define this binary search function later on. So if binary search, which will take as argument list L1 and the current item. So if this item is present in L1, that is binary search returns true. Okay. Then you will do what? L3 dot append item. That means this item is common in both lists. L3 dot append item. Okay. After this,
From this binary search,
I will define
this,
it. Okay. I'll define it after this. So then you do a, yeah, are you asking anything else?
I'm asking, this binary search will only applicable only by writing binary search.
You can write any name, okay? I'm just naming it binary search. The name of the function is up to you totally. Just maintain the name that they have asked in question, like this find common elements. Okay, just maintain this name. Any other function you define by yourself, you can name it whatever you want. Okay. Then after all of this is done, we have gone through every element in list 2 and done the binary search in list 1, found all the common elements appended to list 3. We can come out of the loop
Then we reached.
and return list 3. Okay, simple. Up to this. Any doubt up to this?
No, ma'am.
This error is throwing. Why? Because we don't have binary search function written yet. We'll write it now. So now you define the binary search function. So def binary search. See, these are very basic algorithms. This is binary search, linear search, but these are very important for coding rounds. When people think that they can do it and they don't practice it, and later on they forget the logic, because binary search logic is pretty nice logic, right? You might forget it if you don't have it in practice. So that's why you can always do the lead code problems. Okay, so in binary search, first I need what? The length of the list. So in S variable, I'm storing length of L, whatever list I'm passing, that length. Next, I'll check if S is less than 1. That means if there are 0 elements present in my list, then what will I do? Just return false. Okay, nothing else. But if there are more than 1 elements, or if there are more than 0 elements, right, then you will initialize one variable called left. Now we need 2 pointers, one for the left hand side, one for the right hand side, right? So left pointer will start at which index?
0.
0. Right pointer will start at
And
Length of L minus 1.
S minus 1. Okay, here S is storing the length, so length minus 1, S minus 1. Now you need a while loop. So you can very much relate this with the previous problem, right? So how long will this while loop run? Until left
Left
is
less than or equal to
right.
right.
Correct. Once this is violated, then I'll go out of the loop and return whatever is there. So while left is less than equal to right, first we will calculate what? Mid index. Okay, here I am not using that thing again, that high minus low. I'm just calculating like we do usually. So left plus right, and I'll do a floor division here. Okay. What is happening? Wait. The warning is okay. Mid is assigned to okay. This will be fixed in the next steps. Okay, so mid is first calculated. Next, I will check the first if condition. First if condition is if the element I'm searching for is at the mid, right? That is if k is equal to L of mid. So if we have already found it, so if k is equal to L of mid, this is like that first if condition in the last problem. I have already found the peak. So like that, I have already found the element I'm searching for. In that case, directly return true.
Mid.
No, we don't need the index here, right? The problem statement asks that you return true, right? And
Yes.
here, see why I'm returning true. In this Find common elements. What am I having in the if condition? Binary search will return a boolean value, right? So it will check whether it is present or not and then add the item. So that's why return true. Now, if I don't find it at mid, now I have to again check in the left and right. So elif k is less than L of mid. That means the item that I'm searching for is less than whatever item is present at the middle index. So which part of the array will I search now?
Left part.
Left part. That means which index do I have to change?
High.
Right
High.
index. Right
Oh,
index will
sorry.
become what?
Right.
Mid
Mid
minus one.
minus one.
Mid minus 1. Easy. Next. Okay. Next is the else statement. Else
Low is equal to mid plus one.
left is, here we are using left, you can use low, whatever. Okay. Left will be mid plus 1. That is in
Mid
case,
plus one.
yeah, in case the element that I'm searching for is greater than the element present at the middle index. Since the list is sorted, I can surely say that it is present in the right hand side of the array. So left is equal to mid plus 1. Okay. If this is, if any of these are, uh, if any of these work, right, then at some point I'll find that this condition becomes true, that at some mid I will find my k and I will return true. But if the element is not present in L2, if I find such an element which is not there in L1, in that case I have to return false, right? So you
Ma'am,
also need a, yeah,
we have not yet sorted L. Na?
yeah, we have sorted L here. See, L1 dot sort.
Oh, okay, okay.
Okay. So for that, if the element is not found, we also have to write a return statement for false. So return false if nothing is found. No match is found. Okay, this is my binary search. Is this code clear? Any doubt?
Ma'am,
Here,
so in
ma'am.
exam and all, sometimes like inbuilt functions are not to be used. No, here you have used sort. So will be
Yeah. So
correctly
it's
when you
sort
are
you
not.
can usually sort will, I mean, we will ask you to use, it's fine. If sort you cannot use, then you can use any of the algorithms to sort. Okay. Making sure that the timing complexity doesn't change. So you know a lot of sorting techniques in this week. It has been taught like insertion, merge. You can use merge sort here also. Okay. So you have to write the logic for that. There is one problem in the live problems only. I think the next problem where we will do merge sort. Okay. So there you will understand how to write the code for merge sort.
Week
That
two, I think
usually
only
sort you can. Yeah. Sorry. Come again.
in till the end of week two, it's only till merge sort. I think bubble sort and all are not covered. I think
Yeah. Then wait. Let me check one thing in the portal.
because I have finished week two lectures, but
Mm-hmm. Okay.
third was the end of week two. I think
So in week 2, you are covering binary sort, selection sorts, insertion sort, and merge
all.
sort. Fine, whatever sort is there in the syllabus, you use any of those algorithms. If bubble sort is not there, you don't need to learn. Okay.
Okay.
These are the main sorting techniques that are used because the timing complexity is efficient. Bubble sort takes more time. Okay.
Okay.
There are other sorting techniques also, quick sort, heap sort, but those are not mentioned here, so no need to use. You use whatever is taught. Okay. If it is specifically mentioned, you cannot use built-in sort, then you write the merge sort algorithm or insertion sort, whichever with respect to the timing complexity that you are aiming for. Right.
Ma'am,
Yes.
quick sort is in week three.
Quick sort is in week 3, so we'll learn that. Quick sort is a very nice algorithm. Okay. This is clear. Binary search. The entire code anywhere. Any doubt? Should we run? Okay, let's check. So enter L1. Let's tell me what should be the list. Give me any 4 elements. 1, 3, 5, 7. Okay. L2. Let's put some common elements. So I'll put 1, 2, 5, 9. So what should be in my answer, in my actual list, common elements list?
1 5.
1 5. So 1 5 is there. Okay. If there are no common elements, let's check for that too if it is correctly working. So same list I'll take 1, 3, 5, 7, 2, 4, 6, 8. So nothing is there. So it is returning an empty list. Okay. Because anyways L3 will be returned. So if nothing is in common, nothing will be appended. L3 is an empty list. Okay, the problem is clear. Anywhere, any doubt, any line? Okay.
But where is a check of left list and right list?
This. Here you are changing the right index and the left index. Okay. If k is less than the mid index element, then you go change the right index. That is, you search only in the left part of the list. If k is greater, then you only search in the right part of the list. Okay. Should we check the next question? All right. So Q3. I think Q3 is that merge sort problem. You can see the questions, right, in the portal. Is
Yes.
live coding problems? Yeah.
Yes.
So you also write the code along with me, okay? All right. So this is asking what? See, this question looks difficult. It is not difficult at all. If you have gone through the uh, lectures or you have attended the live sessions, you should be familiar with merge sort algorithm, right? So first tell me, what type of an algorithm is merge sort?
Divide and conquer.
Divide and conquer. In divide and conquer approach, what do we do? Basically, let's say we have a very large problem, okay, and we want to break down that problem into smaller problems which are easier to solve. So we first solve those small problems one by one, then we combine them and we solve the large problem. So you divide the problem and then combine to conquer the bigger problem. So divide and conquer. Okay. Now, this question is asking you have a deck of shuffled cards ranging from 0 to some huge number. Okay. There are two subordinates below you and two subordinates below them, and it goes on like that. Means, let's say I have the deck of shuffled cards. Under me, there are two people. Under each of them, there are two more people. Like whoever is on my left hand side has two subordinates of their own. Whoever is on my right hand side also has two subordinates of their own. And like this, it goes on. This tree will continue. Okay. Now, the job of the subordinate is to split the deck of cards that they received and give it to the two subordinates below them. Right. So, everyone who receives the deck of cards, their job is to split that into two roughly equal halves and give it to their subordinates. If they receive a deck of cards from their subordinates, now this is the what? This is dividing the problem, right? I have a huge deck of cards. I am dividing it into smaller halves. Okay. Now, once I have divided it, I also have to merge it back. Like when I have solved the smaller problems, I have to take the solutions together, merge them, and solve the bigger problem. So once I have given my deck of cards, splitted it, and divided it into multiple people, once it reaches that value where each person maybe has one or two cards, okay. So at that point, they have to also merge their solutions. So in merge sort, what do we do? Those leaf nodes of the tree, that is the last subordinates who have one or two cards. So if they have one card, they directly pass it on to their predecessor or their superior. And if they have two cards, then they can easily, in two cards, you can sort the two cards, right? Two elements are sortable. You sort them and you give it to your superior. So these are what? Once the small problems are solved, they are merged and gone to the higher level, given back to the higher level. Then again, the higher level will also merge its solution and give it to the higher level. Like this, how long will this merging continue? Until we reach the root level, where we have solved the entire problem. Okay. So what they're saying, that if they receive a deck of cards from their subordinates, that is, if I receive, or if the subordinates below me receive a deck of cards from their subordinate, then they merge it in an ascending order. Okay, that means the sorted lists are now merged in an ascending order and give it to the higher level. Okay, now if a subordinate received only two cards, if someone has only two cards, then he or she himself or herself can arrange in ascending order. If you have only two cards, you can obviously sort it and give it to your superior. If someone receives only one card, then he or she will give back that exact card to their superior. Now, after reading this, you tell me if someone has. So, when will this thing occur? Like, when will a person have one card? When will a person receive one card? When their superior has how many cards?
Two cards.
Two
Or
cards.
three cards,
Two
right?
or three.
If they have three, then they can give one subordinate two cards, another subordinate one
One
card.
card.
So these are the two possibilities that can happen. So if someone receives one card, they can directly pass it on to their superior. There is nothing to sort. If they receive two cards, they can sort it in ascending order and pass it on to their superior. Now the superior has now two decks, one from the left subordinate, one from the right subordinate. Both are sorted. Now they have to merge these two lists in ascending order again, and again give them to their superior. Like this, it will continue till it reaches me. I am at the root level and I will merge all the solutions that I am receiving. I am also only going to receive two decks from my two subordinates. I have to merge those two. Okay. So at every level, this merging will happen. So this problem doesn't tell you that you have to do merge sort, right? But by reading it, you can understand that it is merge sort. So like this, see this example. If at 0, right? So the person who is at, let's say, 0th level, that is root level, that person has this deck 3 1 2 0 5, not sorted. So this person will give to their two subordinates, subordinate 1, subordinate 2. So I have divided this list and I have given, since there are 5 elements, it will be like a rough half. One person will receive the first two elements, that is 3 and 1. Another person will receive 2 0 5. Okay, now each of these people also have subordinates. So the person who received 3 and 1, they only have two cards. They don't need a subordinate, right? If you have two cards, you can sort it yourself and give it to your superior. So you sort it into 1 comma 3 in ascending order. Person who received three cards, 2 0 5, they need subordinates. So subordinate 3, subordinate 4 will answer to who? Subordinate 2, right? So subordinate 3 receives 2 and 4 receives 0 comma 5. So 2 can be returned as it is. One card if you receive, you can return as it is to your superior. Again 0 comma 5 also you can sort and give to your superior. So this is already sorted. So 2 will receive what? This 2 and 0 5, and 2 has to merge it in a ascending order way. So what will it be? Ultimately 0 comma 2 comma 5. So now subordinate 1 has 1 comma 3, subordinate 2 has 0 comma 2 comma 5. Both these lists will be given back to root node or root, that is the head person, subordinate 0. So they will have these two decks 1 comma 3, 0 comma 2 comma 5. These two lists they have to merge in ascending order. So finally it will be 0 comma 1 comma 2 comma 3 comma 5, which is a complete sort. So this is your merge sort algorithm, right? So what is your task? Your task is to find how many people, including you, that is including the person at the root level, are required to sort the cards. Okay, you have to find how many people are required to sort the cards. And you have to print what? The sorted deck of cards and the number of people required as a tuple. That means it will be like this. So your function name is what? Subordinates, and it will take the list L, which you have to sort. Now let's say the list is this sample input 1. So your output should look like this. It should be a tuple in the form of a tuple, that is within parenthesis. You first have the first element of the tuple is the sorted list, and second element of the tuple is how many people or how many subordinates it required, including you, to do this sort. Right. So basic idea now. How will I leave the sorting for now? You know how to do merge sort. Okay, you can implement that. But how do I count this? How many people are required? Any idea? How do I count?
It is a recursion number of
Each
recursion.
time we call the merge function, we increase some counter like that.
So each time we call the merge sort function, right? Merge sort and merge are two different functions.
Yeah, merge
So
sort
every
function.
time we call merge sort, that means one more person is added,
Yeah.
right? One more subordinate is added. So we can have a counter C, which we will increment every time we call that merge sort. So we can have a global variable C, which I can define at the start, and then I can use that variable in my merge sort function and increment its value, right? And when I actually return whatever is the result in the form of a tuple, I can use that C variable. So that's the
Ma'am,
idea.
if the variable becomes the highest value, that is 7, so we will stop calling merge sort again.
No. Merge sort doesn't depend on the variable. The variable depends on how many times merge sort is being called.
Ma'am, but 7 will be provided to us, no?
No. You have to calculate. This
Okay, okay.
7 value came how? It
Okay,
means that
fine.
how many people are required to do this sorting. So
Okay,
that
ma'am,
will
got it.
find out while you sort. Okay.
Yes, ma'am.
So what do I need to do here? First of all, what are the functions that I will need?
Merge and merge sort.
And a
You
subordinates
need
function, right?
Yeah.
and,
So that
and you need
subordinate,
to keep a count.
correct. So that subordinate functions will take the initial list as input. Okay. So that will take the list and then it will return the merge sort, uh, whatever the merge sort function returns and the counter C. So C can be used as a global variable in this question. I can declare C outside of the scope of any function. I can globally declare it, and if I want to use it inside any function, I can call it by writing global C. So I'll be using that or updating the value of that variable. Listen, whenever we want to update the value of a global variable inside a function, right? Then we have to like declare this statement that global C. This means what? That I will be using the variable C, the global variable, and I'll be changing its value. Now, if I don't want to change its value, I just want to print it or return the value somewhere. Then I don't need to declare it separately, that global C. You can just write, you can just use it whatever, wherever you want in the return statement. Okay. Who is joining now? Wait. Okay. So we need to write merge sort subordinates. Okay, let's start. Problem statement is clear for everyone?
Yes, ma'am.
So it is always good. See, I don't know if I don't think any of you had Python with me, but in Python also I say this, that always know these utilities, right? In Python we have all these built-in functions which are not there in other languages. So always know how to write a search function on your own, how to write a sort function on your own. Okay, all the methods that you have built in, you should also know the logic behind them. So this is a very good program. Here you will know how to do merge sort, which is used in the time sort algorithm that Python actually uses. So first let's write the subordinates. So define subordinates. It will take list L. Okay. And it will return what? I'll take input list L outside of the function. Don't worry. So it will return what? Whatever merge sort gives, and the counter C, which will be storing what? The number of people that are required to do the sorting, or the number of subordinates. Now we have to declare C globally. So C I'm declaring with initialized value 0. Then I am taking input here. Let me write a print statement. So print, uh, I can write it like this: subordinates. You can take this input directly also, but you can write like this too. Subordinates. Wait, the spelling is wrong. So I'm calling the subordinates function, right? And I'm taking input in the argument itself. So eval input, enter the list or deck of cards, whatever. Okay. So I take the list, then I call subordinates. So this list will be taken as argument to subordinates function. Control will shift to this line 1, and it will then call what? Merge sort. Right, in the return statement it will call merge sort. So next we will write what? Merge sort. So define merge sort. Now merge sort function can be written in different ways. I'm going to write it in a very short way. See, merge sort idea is what? First we need what? We need the counter, right? Every time merge sort is called, that means one more person is added. So first let's declare that I'll be using the global variable c. So write global c. Once you write the statement, you will be able to update the value of global variable. Then we do c plus equal to 1. Okay, so first increment c, get that out of the way. Now the merge sort logic. First in n, okay, in a variable n, I will be storing the length of the list that I took as argument, which I have to sort. If the length of the list is less than equal to 1, that is there are 0 or 1 elements present, then I can return it as it is, return L. If the length of the list is 2, right, 2 elements are present, that means a little sorting is required. So for that I will not be calling a merge sort function. I can
Yes.
just, what was given in the problem statement, if you have 2 cards, you can sort it yourself and return it to your superior. So I will check if L0 is less than L1, okay, then I will return L as it is, and if it is not, then I'll just return the reverse list L1 comma L0. So let's write these conditions first. If n is, okay, first n I have to define, n is length of L. Okay, now if first condition n is less than equal to 1, that is list contains 0 or 1 elements, in that case I will directly return the list back. Okay, next other condition is what? If n is equal to 2, there are 2 elements in my list, then I can return what? Return L. If, when will I return the list as it is? If L0 is
Greater than L of 1.
less
Less
than,
than
it is
L of
ascending
1.
order, right? So less than L of 1. Else, just reverse the list. So colon colon negative 1. You know the slicing, right?
Yes, ma'am.
Negative index. So this is for list with 2 elements. Now we come to list that has more than 2 elements. So there I need the merge sort. So now I'll define one more variable m, inside which I'll store floor division n by 2. So what is floor division n by 2? The middle index, roughly the middle index. Okay. So now the list is divided. So every time I get a list which has more than 2 elements, I need to divide it and give it to my 2 subordinates, right? So one is my left subordinate, one is my right subordinate. Now I have the midpoint which is stored in m. M is the mid index. So next line, define your left subordinate L. So L, inside L I will call merge sort again. Right? This is the first recursive call. Now what is the argument of this merge sort? The left part of the list. That is list. I'll slice it from beginning to the m minus 1th index. This. Right. M is not included. And the right subordinate, same again call merge sort. What will be the index? I'm sorry, 2 equals not required. Yeah. What is the index?
M colon.
L of m colon. Right? That is from m till the end of the list. So these are my 2 subordinates. Now they will do merge sort
M.
on these lists. Yeah, any question? Okay. So once they have sorted, right? Obviously there will be many more recursive calls inside them, right? They also have to break down their list into 2, again into 2, until some person at the leaf level receives a 2 cards or 1 card. Up till then we will keep on continuously calling this merge sort function, right? Now when this is done, when my left and right subordinate have given me back their sorted lists, then I need to merge them, right? So I will write what? Return some function merge, which takes both my left and right lists. Now this merge function I have to define. But is the merge sort function clear? What is happening here?
Yes, ma'am.
Okay, see, these are recursive calls. Okay, these will be called again. Now, once I come to this line 10, the first iteration, okay, when I do this for the first iteration, then it will go, let's say my middle index, my list has 10 elements, my middle index is at 5. So the left will have 0 to 4 index, right? And the right side will have 5 to 9 index. So again, when I go to this assign this left hand subordinate, this merge sort, I call the function again recursively, and it takes index 0 to 4. Okay, then again 0 to 4 will be divided according to the midpoint, right? Again 0 to 4 will be divided, maybe 0 1 to 1 left subordinate, 2 to 4 to the right subordinate. Like this, it will keep on calling until the left and right subordinates receive one or two cards each. Okay, at that point this condition will be satisfied, right? If you have one card, you can directly return it, or if you have two cards, you can sort it and return. So till then, you keep on calling merge sort in both subordinates, left and right. And once you get the result back for every call, you have to do a merge. You have to merge both subordinates' result, and then you can give it back to your superior. Right? Up to this, it is clear, I hope. Then we will do the merge function itself. Define merge. So what is merge taking as argument? Again, two lists, A and B. Okay. Now let's take two more variables, M and N. Okay. So M and N are storing what? Respectively the lengths of
Length of A and B.
A and B, correct. So length of A, comma length of B. So length of A, comma length of B. Now we need three more variables. Okay. See, you can write this function in a different way also. Okay, this is not the only way, but this is an easy way. So C is one variable I'm taking. I'm taking I. Also, I'm taking J. I'm assigning these what value. C is what? A list where we
Empty
will
list.
keep the merge values. Yeah, sorry.
You're saying empty list.
Yeah. So C is an empty list. Why? Because this is where we will merge the two lists and keep the merge list in C. Right. And I
Yeah.
and J are what? I and J are indices we need to traverse the two lists A and B. Okay. Any question up to this?
No, ma'am.
So, ma'am, I and J, can you again
Yeah. Look, now I have to do what? To merge. I have two lists and I need to merge them in such a way that they're in ascending order. The merge list is in ascending order, right? That means I have to
yes.
compare elements from both lists. So if I take AI and BJ, these two elements, I have to compare them. Okay. And whichever is the smaller one will be appended to C first. Correct. That's the logic. We have to compare every two elements and then we will append the smaller one first and then the bigger one. Right. So I
Okay.
and J are these two iterator variables. I will be used to iterate through this A list, J will be used to iterate through the B list.
Okay, ma'am.
So
Got
the
it.
comparison logic I will now write. So while I less than M, okay, while I is less than M is what? Length of A. So till when I am going to run this list, either if I gets exhausted first, that is I becomes M, that is I have gone through every element in A list, or if J gets exhausted first, that is B list gets exhausted first, I have gone through every element in B list. So not necessarily these two lists are going to be of same length, right? One list can have three elements, one list can have two elements. So in that case, when we are doing the comparison, since these are distinct elements, I'm uh, assuming, so in that case what will happen? One list is bound to get exhausted before the other one, right? So that will violate the while condition. So either this will violate, I will become M or J will become N. Whichever list is shorter will get exhausted first. Okay.
Ma'am, if we are taking and, so it should make sure that both are giving a true, right? So if it is not of the
Yeah,
same.
that's why. See, if it is not of the same, so at some point, if I becomes m and j is still less than n, then it becomes what? Condition becomes true and false, which is false. That means you can come out of the loop.
Okay. Okay,
Okay.
ma'am.
As long as both are true, you will keep on running the loop. That means there are more elements left in both lists. Now, what is the logic? If one list is exhausted, that means all elements from that list has been appended to C, and one list that is not
Okay.
exhausted, which still has elements. So those elements are definitely what? Bigger than all the elements of the other list. So they can just be directly appended to the last end of C. Okay.
Oh, okay, ma'am.
So
So
while
the
I,
comparison, to stop the comparison, we are doing this step, right?
yeah, to come out of the while loop, we are going to wait until one of the list gets exhausted. Okay. So while this condition is true, now do the comparison. If a of I, that is first element in ij both starting from 0. So first element in A, okay, first element in A list, if it is less than first element of B list, then we are having this C list merged in ascending order. So which element will be added to C?
Yeah, okay.
A of
AI.
I. So C dot append A of I. Okay. If that is not true, okay, as soon as you do C of append A of I, that means C dot append A of I, that means one element is gone. Okay, we have checked for one element. Now we will check for the next element in A. So I needs to be incremented. So I
Yeah.
plus equal to 1. Now if this is not true, if B of j is less than A of I, that is the other case. So write an else block. Else C dot append what?
B of j,
B of J.
Then
increment j.
increment j.
Yeah. Yeah.
Okay. Now this process will continue till one of the list gets exhausted. That is either I reaches m or j reaches n. So we don't know what list will get exhausted. So we will have both the options. So after we come out of the while loop, I'll write c dot extend. You know extend function?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes,
Yes,
ma'am.
ma'am.
Extend
All
means if
lists
I
are
have a
added.
list, correct. If I have a list A and a list B, okay, and I write A dot extend B. That means whatever elements are present in B will be added to the end of A. So same thing I'm doing here. C list now has some elements, right? Let's say I got exhausted. No, let's say B list got exhausted first. So that means there are still some elements left in A list which are not added to C, right? And those elements are definitely in ascending order. So what will I do? Because this A and B lists are in themselves sorted, right? So they are definitely in ascending order. So extend, I need to add the remaining elements in A list. So A from which index? The current I index till the end. So append whatever is left in A list to the C list end. This is one thing that can happen. Other possibility is that there are still elements left in B list which are not added and A list is exhausted. So same thing, just C dot extend
B
B
of j column.
jth index to the end. Okay. Now both of these statements will be running anyways, right? After we come out of the loop, whether A is exhausted or B is exhausted, I don't know. So both statements will run. If there is nothing, if I is equal to m, then obviously nothing to add, right, from A. And if j is equal to n, then nothing to add from B. So anyways, whatever elements are left in either A or B will be appended to C at the end of C. And then we can simply write return C. So is this successfully merged, two lists A and B in ascending order?
Yes, ma'am.
Any doubt in merge?
So instead of doing that if else thing that I is less than n, you have
Hmm.
extended both of them. It will extend an empty list, like nothing if
Yeah.
anyone is empty.
Yeah. Let's say if A gets exhausted first, that is I becomes equal to M, right? Then nothing will be left in A. So even if this line 11, this runs, nothing will be added to C because A is empty,
Empty
right?
list.
I mean, not empty, but I is what? It is starting from ith index. That is the last index. It has already reached the last index. So nothing else to add. And if B is exhausted, then J is at the last index, nth index, nothing else to add. So whichever has something left, only that will be extended. Okay. So all three functions, is it okay with everyone? Any doubt?
Ma'am, can you explain the second function once again?
Merge, this one.
Much sort.
Merge sort. Okay. So merge sort does what? Merge sort is when you divide the list and give it to your subordinates. That is the merge sort. Okay. So I get a list L, a deck of cards, list L. I need to give it to my left subordinate and right subordinate in a roughly half. Right. So first I need to also keep a count of how many people are involved in this comparison process or this sorting process. Right. So for that I have global variable C. So every time I enter merge sort function, that means that one more person is added to the whole thing. Right. That is one more subordinate is added. So C will be incremented in the beginning. Then we need to find what? That how many elements are in my list. So if my list contains less than one, or there is 0 or 1 elements, that means it is already a sorted list, right? One element is a sorted list. So you can directly return that if n is less than equal to 1, return L directly. That is what is given in our problem statement too. If you receive only one card, you can directly give it back to your superior. If you receive two cards, that is your list length is 2, then you will return what? You can return the list as it is. If L0 is less than L1, that is list is already in ascending order. If it is not sorted, you can just return the reverse of the list since there are only two elements. If 0 is less than 1, then fine, return it as it is. If the other thing is true, that is 1 is less than 0, just return the reverse list. Okay. Now if I
Ma'am,
have,
double colon is for reverse.
yeah, this is reverse. Okay. Negative index is in slicing. Negative index 1 means the last element. So you're starting from last element going to the first element. Okay.
Ma'am,
Yeah.
what the time complexity this slicing takes?
Slicing takes.
Hmm.
Slicing time complexity, I think it depends on like from which index you are slicing. Okay. So if
Hmm.
there are n elements and I'm slicing, I think it will be some constant complexity based on which index I'm slicing from. The entire merge sort, this entire merge sort procedure will take n log n time. Okay.
Hmm.
But
This
yeah,
will this takes order of n? The,
the
The
slicing.
merging takes
slicing.
order of n.
Hmm?
The merging part will take order of n time.
Just give me 1 second. I'm getting a call.
Merging. That is the best case. No?
No, no. In all cases,
Worst case.
if
Yeah,
two
yeah.
lists
One
are
second.
sorted,
I'll explain this. 1 second. Just I'm getting a call. Wait. Hello. No, you can send me it over in mail or something. Okay. Okay. I'm in a class right now. I'll get back to you later. Okay. Just give me a minute. I'll check my mail once. Yeah. Am I audible?
yes, ma'am.
Yes, ma'am.
Okay. So how it takes n log n, right? Merge sort, how it takes n log n, I'll explain. Okay. This, see, where are we dividing the list? First tell me, where are we dividing? In merge or in merge sort?
Merge sort.
Mod sort.
Merge sort.
So whenever we divide a list in two, right? Every time we divide something in half, what is the time complexity of that procedure?
Log n.
Log.
Log n.
Log n.
Base 2.
Okay, log n. Now, in merging, how many times do I have to merge? As many elements as there are. Okay, because at the end,
N.
in the leaf nodes, okay, what will happen? One thing can happen is that every subordinate has one one. Okay, every subordinate gets one card. Okay, that can happen if it is an even list. Let's say every subordinate can have one card. So if I have 8 elements, every 8 subordinates at the leaf level will have one card each, right? And they have to be merged together. So for n elements, I have to do the merging. So n times I have to do till I reach the root level, right? The merging will do for each level. So what will be that height of the tree also? That height of the tree will also be log n, right?
Yes, ma'am.
Just like your binary search. So at the root level, I have the entire list. Next level, I divide the list in two. Next level, you divide it in four. So like this, you will divide till when? When everyone has one card. Okay, or a better
Yes,
way,
ma'am.
Till we reach the leaf.
till we reach the leaf. So that height of that tree is what? Log n. And how many times are you merging? N times for n elements.
Yes.
So n log n.
Yes, ma'am.
Okay. Yeah. Is the code clear? Any line, any difficulty you're having?
Ma'am, in merge sort, can you explain the conditions like
Yeah.
yeah.
Look, one condition is that if I receive a list that has 0 or 1 elements, so that list is inherently sorted, correct? I can directly
Yes.
return it to my superior. If my list has 2 elements, I can sort it in ascending order, return it to my superior. If my list has more than 2 elements, this is what I was saying. If it has more than 2 elements, then I have to divide that list and give it to two more subordinates who are below me, right? Who will report to me. So for that, I have this m equals to n floor division 2. So this m is storing the rough midpoint of this list L. Okay. Now to my left subordinate, I am giving the left part of the list. That is from 0th index to m minus 1th index. And to my right subordinate, I am giving the right part of the list. That is from m index to n minus 1th index. That is last index. Okay. But I am giving this as argument to merge sort again. Because are these lists sorted? No. I have to sort the lists, right? And when will I stop calling merge sort? When I have either of these two conditions, either the length of the list is 1 or the length of the list is 2. Then I will not call merge sort anymore. So at the leaf level only, I will find these base conditions, right? These are the base conditions to stop the recursive call. So once I reach the leaf level, I will find these conditions and I can directly return the list. They will be returned to the last call, then the last call before that. Like that, it will come and merge, right? After every return statement that happens, that is this C. Return statement does what? Merge list L and R. So let's say at the leaf level, there are two subordinates. One is the left subordinate, one is the right subordinate. Okay, of some particular node. And they both have one card. Okay. And they both have returned. So after they have returned, then these left and right lists containing one card have to be merged. So merge L comma R. Then you go back to this merge function and you merge them. Okay, in ascending order. Then after you merge them, this merged list goes back where? The superior is also the left or right subordinate of some higher node, right? So then he will return. Again, the right or left, whichever other subordinate is left, they will also return. So every step, two lists are being returned in sorted order. And then they are merged in ascending order. Okay.
Ma'am,
Ma'am,
uh, for n equals to 2, what is exactly happening in a list? Can you
See,
explain
if
this
there are,
particular?
yeah, let's say the list contains the elements 4 comma 5. Okay, that is n equal to 2,
Yes.
length is 2. So
Yes.
you can directly return this list If L0 is less than L1, so what is L0? 4. L1 5. Yes, 4 less than 5, directly return it. But if my list was 5 comma 4, then L0 is not less than L1. So in that case, we will return the reverse list. So if I reverse 5
Oh,
comma 4,
okay.
I'll get 4 comma 5. Okay, that thing only I've written here.
And ma'am, the global C and C plus equals to 1, what is this
So C
doing?
is the counter. In our problem statement, we also have to print what? That how many people are required, right, to do this merge sort, the entire procedure to sort the entire list. How many people are required, including yourself? So for that, to count that, I can understand that every time I call a merge sort, where am I calling merge sort? In the left subordinate and then in the right subordinate. That means every time I call merge sort, it means one more person is being added, right? So at every call of merge sort, I need to increment this variable C. This is the counter of how many people are being used for this entire procedure. So C I have declared globally here in line 36. I have initialized it with 0. And since I want to change the value of C, right, inside this merge sort procedure, C's value is constantly being updated. Every time it is called, the value is incremented. So if you want to update the value of a global variable, in that case you have to mention this statement. If you want to update the value of a global variable inside a function, then you have to mention global C, that is variable name, and then you can do whatever you want with that variable.
Where is C declared,
Does
ma'am?
C is declared here globally at the end.
Okay.
does
Ma'am,
that
one question about. Okay.
does
Okay, you
that
ask.
mean okay? Does that mean number of subordinates is getting counted?
Yes, yes. Not just subordinates, the root also. That is, if I start, if I have the initial deck of cards, then under me there are two subordinates, under them there are four subordinates, then 8, then 16, like this. So the total number of subordinates, including me, will be in this counter. Because the first time the merge sort is called, that is for me, right? I am doing the first division. So for that also I am incrementing C. So here I am being counted too.
So the height of the tree is getting counted.
Not the height
Is
of the
it?
tree, the number of nodes in the tree. Okay.
Okay. Okay.
And height of the tree is what? If number of nodes is C, then height is what?
-1.
Height is,
Log of
height
C.
depends on,
Log
no,
base 2 C.
height depends on how many elements you have in your list. If I have n elements, height will be log n.
Oh, okay. Okay.
Okay. Yeah. Any other question from this?
Ma'am, ma'am, this there are two recursion calls, right?
Yeah, two
In
recursive
the
calls.
master. So the first recursion call will be resolved till the end, right?
Yeah. So first recursion call will, first we will do the left side. Okay. For the left side, first subordinate, first we will go till the leaf. Okay, until we have that one card. Then only it
Correct.
can return back. Okay, and
Yes,
once
ma'am.
it returns back and comes back to the first initial call, then we can go on to the next line, that is the right subordinate, and do the same. Okay, not together, they won't run together, one by one.
Correct. So ultimately, when L is going to have one component and small r is also going to have one component,
Hmm.
then merge of L comma R. This should have been a simpler function. No, it should have been just L comma R. I mean, sorry, L
It,
appended
I
with
mean, you
R.
are saying just because one element in each, right?
Because merge
but
sort
but think about the
requires.
higher levels. Now they are giving back to their superior, so now their superior has a list which is of two elements, but their superior is not the root. That superior is also some left or right subordinate. So if it is a left subordinate, it has a corresponding right subordinate too, who also, let's say, has a two element list. Now these two
Okay,
element list also needs to be merged, right?
understood. Understood.
Okay. Yeah. Anything else? Let's run this once, we haven't run it. Have we run? This was, no. Okay, so we have to give a list and then it will check how many people are required. So let's just take one of the test cases. Mm, yeah, let's take this test case. So 19469, this list I'm taking. Oh, I can't copy from here now. Wait. Yeah, let's take from here. So I'm not exactly using any of this. I think these solutions will be made available to you, but I'm not using the exact solutions. Okay, you can write code in your own way, whatever looks easier. So this is the sample input I'm taking, 194.69, this list. So how many elements it has? 8 elements, correct?
Yes,
Now
ma'am.
think of it in your mind, just do the mental math. Okay, I am the first person, I get this deck of 8 elements. I have to give to two of my subordinates. How many will each receive?
4.
4, 4. So how many people involved till now?
Two people.
2.
3.
Three people,
Three. Three
including me.
people. Yeah.
Me and my
Okay,
left
okay.
and right subordinate. Now my left
Yes, ma'am.
subordinate has 4. He will also have two more subordinates. How many do they have each?
2 each.
Two
Two
each.
each. Do they need more subordinates?
Yes. Oh, no, no. In
No,
our
no,
case,
no.
no.
If I have
Because,
two, I can directly
yes,
have
yes,
them in ascending order and return.
yes,
So
Yes,
left
ma'am.
subordinate has, my left subordinate has two subordinates who each have two cards each. So till now, how many people in the process? 5.
yes,
Yes, ma'am.
Also, my right subordinate also has 4 elements. He also needs two more subordinates, each having 2.
yes,
So total, how many people? 7.
7.
7.
So if my program is correct, it should give the output like this: the sorted list, comma 7. That is 7 people. Okay, let's see. Could be wrong because I just wrote this. We'll debug it if something's wrong. So enter the list. Let's hope. Yeah. So list is sorted. 7 people. Okay, that means program is running correctly. Okay. Should we go for the last question?
Yes, ma'am.
Ma'am, can you explain that global C part, ma'am? Do we need to write this global C in merge as well? Because we are,
No, in
sorry,
merge you don't need, no?
in subordinate, sorry.
No, no. In subordinate, in the return statement you need to write because this is
No,
the
no, no.
ultimate return.
This global C part, ma'am, which you have written in merge sort.
No, no. See, in this subordinates function, I'm not
Mhm.
updating C anywhere, right? I'm just returning the value.
Okay, so
So if
we
you
don't
don't
need
need
to
to
mention
update,
it.
you don't need that global C. Yeah.
Okay, okay.
Okay. Now the
Ma'am,
last, yeah,
can you provide the first code?
I'll provide all the code. Okay, just some. I'll provide on discourse. Fine.
Ma'am, why we are taking global C?
Globally, I'm declaring this variable because this variable is used in more than one function, right? It is used in
Okay.
subordinates also. It is used in merge sort also.
So global keyword should be at the declaration, no, ma'am, not
No, no,
inside the
not
function.
in declaration. In declaration, you don't need to use the global keyword. If you use a variable outside the scope of any function, then it becomes global automatically in Python. Okay. Now, if you want to use that variable inside some function and update the value, then you need to use the global keyword. Okay. If you don't use this, then it will think that this C is local to merge sort.
Okay.
Ma'am, go to next question.
Yeah. So, question 4. This is an easy question. It won't take much time. Okay. So now we have a list L of random numbers and another number called pair sum. Okay. So we have to find whether there exists any two number in the list whose sum is equal to pair sum. Okay, very straightforward program. See, if look at the sample input. If I have this list of elements, okay, 10, 4, 11, 5, 1, 8, 7. This is the list and the pair sum is what? 21. So I have to check that in my list, is there any two numbers whose sum is equal to 21? If yes, if you find any such pair, you can return true. If there are no such pairs, you can return false. Okay. So we have to write the function called find pair, which takes L and pair sum as its arguments and return true if there exists a pair or false if there doesn't. We need to write a solution which takes n log n or better time. Okay. There is a hint which says try to sort the list first. So tell me, you should now have some idea how to solve this problem.
Ma'am, we'll sort the list, take the sum which is given to us and subtract it from the first element and search that remaining difference part in whether it is present in the list or not.
That is one way you can do. Yes, you can implement that. Okay. I thought of doing it in another way. I thought I will first sort the list, then I'll take two list pointers, left and right. Okay. Left one will start from 0th index, right one from the last index. Now, as long as left is less than right, I'll run a while loop. Okay. Then I will do what? For each iteration of the while loop, I'll calculate the sum of the left and right. Okay. Left and right indices, I'll calculate the sum. If the sum is equal to x, I'll directly return true. If it is not equal to x, I'll check if the sum is greater than, if the current sum that I've calculated by doing L left plus L right, if that is greater than the x or the or the pair sum. That means which index should I modify?
Left index.
Right index. If the current
Right.
sum is greater, that means since it is a sorted list, so I need to come to the left hand side more, right? So I will do right index decremented
Ma'am,
by
didn't
1.
get you. Ma'am, can you repeat, ma'am?
Okay,
Yes, ma'am. I have applied same idea.
yeah, let me write the code. Okay, then it will be clear. I won't just say it. Let me start writing. Problem statement clear for everyone, right?
Yes, ma'am. Clear. And I have write a code all cases run.
Okay, very good. If is the timing complexity you have checked? Correct? Is
Yes,
it n
ma'am.
log n?
Yes, ma'am. My time complexity correct.
Okay, and very good. Okay, now rest of you, you can see. First, we need to take input, right? We'll take the list as input. Let me increase the font. So inside L, I will take int item. So I'm taking the entire list as a string, okay, and then I'll split it and then convert each element into integer. So int item for item in input dot split. Okay, tell me, is this statement clear to everyone? See, input. This is where I'm taking the entire list as a string input. Okay, and I'm splitting it based on white spaces. So now each of these elements in the string are now converted into a list of strings, right? Where each element is one
String
element
type.
from that string. Right now, each of these strings I need to convert into integer. So for that, int item for item in this entire list of strings. Okay. So now I have an integer list. Next, I need to also take input the pair sum. So for pair sum, just take a normal int input. I'm not writing anything in the inside that input. Okay, we'll understand what it is. And lastly, we have to print just the boolean value we need, and that will come from find pair function. So find pair. What will it take? L and pair sum.
Pair sum.
Okay, this is the suffix code. Now let's write the definition of. We'll write this in one function only. Def find pair, which takes L, comma, some value x. Okay, first I will sort my list. Okay, L dot sort. How much time does this take?
N log n.
N log n. Done. Then I will initialize two pointers. So I am scanning from both ends of the list, left and right end. So left end is starting from index 0. Right is starting from index length of
Length of L
L.
minus 1.
Correct. Length of L minus 1. Okay. One pointer at the beginning, one pointer at the end. Now my while loop. While, how long will I run? Until left remains less than right. Okay. I will formulate the sum. for each iteration. So sum will be what? L of left
plus right, L of right.
plus L of right. Correct. This is stored in sum variable. Next, we will check if the sum that we calculated is exactly equal to the paired sum x. Then return true. That
True.
is, one such pair exists. If the current sum is not equal to x, so else if sum is greater than x. Greater than means what? Since this is a sorted list, that means I need to change the right index. So I will come to the left hand side of the list more, right? To the smaller
Yes,
element. So right minus equal
minus
to
1.
1. Decrement it.
Ma'am, didn't get that, ma'am. Can you please repeat once more?
See, it is a sorted list, right? If the
Yes.
list is 1, 2, 3, 4, 5 like this. So
Hmm.
I am first adding 1 and 5. So that is giving 6, right? If my sum, pair sum is 5.
Hmm.
So in that case, do I need to move the left pointer to the right or right pointer to the left?
Right pointer to the left.
That means we need a smaller sum. So that means we need both values to be smaller, right? So what is the greater value? Whatever is at the right index. So I will
Okay.
shift it to the left. So
Okay.
now we have a smaller value at the right index. Else, if the sum that we calculated is less than x, then what we will do? Increment the
Go
left
to the
index.
right half.
Yes, go to the right half more. So left plus equal to 1.
1. Yes.
Okay. These are all the cases. Now, if I don't find any such pair, for that I need to return false. That's it. That's the program. Okay. So to do just a little bit of a dry run, if I do so, at some point like this 1, 2, 3, 4, 5 list I said, right? If my pair sum is 5, so there are pairs like that, right? 1 and 4. That's one pair. So for the first iteration, left is 0, right is, if I have 5 elements, what is the right index? 4, right? Left is less than right, fine. First iteration. L of left will contain 1, L of right will contain 5. My list is 1, 2, 3, 4, 5. So 1 plus 5 is 6. Is 6 equal to my pair sum, which is 5? No. Is 6 greater than 5? Yes. So I need to come to the left hand side of the list. That is, I need to shift my right index to the left hand side. So right index now points to 3, which contains 4, right? So index 3, that is my list index 3 contains the element 4. So next iteration when I go, left is still less than right. I calculate the sum. L of left is still the 0th index element, that is 1. L of right is now pointing to the index that contains 4. So 1 plus 4 is 5. 5 is equal to pair sum. Yes, return true. So that will return where? To wherever you called that, right, in this print statement. So this will print true. Okay, find pair is not defined.
Ma'am, first line find pair, the spelling is
Okay,
wrong.
okay, okay. Thank you. Okay, is the code clear to everyone? Any doubt? Okay, you can ask. We have run out of time, but you can ask if there is any doubt. Okay, let's run this.
Ma'am,
Yeah.
the conditions sum equals to x. What it is?
X is the pair sum. Okay, that is the sum we want to check. Like in this test case, you saw na, that I have a list and I give the pair sum, that 21. So are there any two elements in my list who add up to 21? That is what I'm checking. So X is that pair sum, 21. Okay.
Okay, so if it is there in the list or not,
If
that
there are any two elements in the list whose sum will give me that pair sum, then we return true, otherwise false. Okay. For that,
and what is elif and else?
so every time we come into this while loop, for every iteration, we are calculating a sum, right, of the left and right indices. So if we find the pair of left and right indices which formulate this same pair sum x, then we return true. If we don't find it, then there are two possibilities. Either the sum I calculated is greater than the pair sum. In that case, you have to shift the right index one index to the left, right? That is to a smaller value since my list is sorted. And if the sum that I've calculated is less than the pair sum, that means we need a greater value. So you need to shift the left index to the right. Okay. And then the next iteration, you again calculate the sum of the new left and right indices. So like this, if there are any such pairs, you will find it because we are checking for all combination of pairs. Okay. And that point you can return true. If there are no such pairs, you can return false.
Ma'am, in why we are not checking left less than or equal to right?
No, left less than or equal to right means what? Then they will merge at some point. That means left and right can both indicate the same element. Right? That we
Oh,
don't
okay.
want. So as long as left is less than right. For that we'll check all combinations.
Ma'am, can you show this in a list? Like sum
Yeah,
is
yeah.
greater than x. So
Look, I'll just quickly write it. See, if this is my list, 1, 2, 3, 4, 5. Okay. And my pair sum is 5. Fine. Left index is starting at this. This is left index.
yes,
Right is starting here. So first
yes,
iteration, we'll check that left is less than right. As long as this is true, we'll run the while loop. So first iteration, what is L of left plus L of right?
6.
1 plus 5.
6.
That is 6. Now, in the first if statement, you check is 6 equal to pair sum, that is 5? No.
No.
So go to else if. Is 6 greater than 5?
Yes.
Yes. So change the, that means
Right.
what? We
Right.
need a smaller value. So
Yes.
change the right index. Right minus equal to 1. So right index now becomes what? Indices were 0, 1, 2, 3, 4. So right index now becomes 3.
3.
Okay. Next iteration when you go, second iteration, left is still at 0. Right is at 3. So what is the new sum? 1 plus what is that third index? 4.
4.
So new sum is 5.
5.
Then again check the if statement. Is 5 equal to desired pair sum?
Yes.
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 So return true. Okay.
Ma'am, can you show one more example? Take the list of even numbers 2, 4, 6, 8, and try to find number 5 in that.
2, 4, 6, 8, and we are trying to find
Yeah,
what?
5. Pairs
5
of
is the
5.
pair sum.
5 is the pairs.
Yeah, just a second.
How is that possible?
Yeah,
These
yeah,
are all
I'll show
even
you.
numbers.
See, that is not possible, but at that case, we also have the false, right? So
Yeah,
if
it
there is
will
no
come
such,
out false.
yeah, it will
Yeah.
come out as false. But how will the checking go? So pair
I
sum is
want to see the
dry run, yeah.
control flow.
So this is left,
Okay, my
right? This
apologies.
is left. This is right. Starting at 0th index, 1, 2, 3. Okay. Left is less than right. Initially, we have to check. 0 is less than 3. Fine. So first iteration, what is the sum? 2 plus 8.
8.
That is
8.
10. 10.
10.
Check. Is 10 equal to 5? No.
No. It is greater than 5.
Else if 10 is greater than 5? Yes. Right index is shifted one place to the left.
Left side.
That means right index is now
2.
2. Okay. Second iteration. Left is still at 0. So what is the sum? 2 plus
2
6.
plus 6.
8.
6. 8.
8.
Is 8 equal to 5?
No.
No. Is 8 greater than 5? Yes.
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 So right index is again shifted one place to the left. Now right index is what? 1.
1.
Third iteration. Third iteration left is still at 0. So sum is 2 plus
4.
4 now.
4.
6. Is
6.
6 equal to 5?
No.
No.
No. 6 greater than 5? Yes.
Yes.
So right
Yes.
is again shifted one place to the left.
Yes.
That becomes what? 0. Next iteration when you go, this left less than right
Is false.
while condition is invalid
Yes.
because both are 0. So then you come out of the loop and you return false.
Yes, ma'am.
Yeah. Okay. So these are all 4 problems. I'll give you the code. I'll
Ma'am, for this, what will be the complexity like
n log n.
n
Okay.
log?
Yeah, because first of all you are doing a sort, right?
Yes.
That will take n log n. And then you
Okay.
are doing this comparison. That is 2 pointers coming, one from left and one from right end. But check one thing: is any variable, is any element repeated? No. You are always having unique sum, right, for every iteration. Either the right is
Yes.
index is shifting or the left index is shifting. So that means every element is checked just once by the pointer. So if there are n elements, that will take n time. So anyways, overall time will be n log n because of the sorting.
Okay. Okay.
Ma'am, where can we find the code? Your code.
See, all these 4 problem codes, I think the solution will be released to you. Anyways, I will give you all this code in a drive link. Okay, I'll share it on Discord today or tomorrow.
Okay.
All right. Yeah, that's it from my side. I hope this was understandable for you.
Yes, ma'am.
Any, if you have any feedback like regarding anything that you would like me to change, you can let me know definitely. Okay. Yeah. Thank you. Thanks for joining everyone.
Thank you, ma'am.
Thank
Thank you,
you.
ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.